Okay, guys, this is geotrig, day 2 of lesson 14. Okay, the one we didn't record were the 2 slides beforehand. We talked about them. So we got SOHCAHTOA, sine, cosine, and tangent. We'll go quickly over these. That sine is the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We use the acronym SOHCAHTOA. Some old hippie caught another hippie tripping on acid. Or Chief SOHCAHTOA. It's the way I learned it. Not so politically correct. But, guys, these only work in right triangles, 90-degree triangles. And these ratios also can be formed to find an unknown angle we sometimes call theta. That was all that we did there. Kind of quick review. And then, in order to find theta, or to get theta by itself, we can take the inverse trig functions. Inverse sine, inverse cosine, inverse tangent. You guys remember talking about that? Which are basically underneath your second function of sine, cosine, and tangent on your calculator. And when, again, you're working with sine, cosine, and tangent, you must first mark off the blank that you are working with, the angle, and so therefore you can label your sides. And we went over that. I remember drawing triangles on the board, and we marked, say, if I was from angle A or from angle B, that I could figure out that the opposites and adjacents change. Hypotenuse will never change, right? Okay, so now we're going to use that information to solve this triangle. I need to solve for angle M, and I need to solve for side X. Now, hopefully, everybody right now says, hey, that's a right triangle. I'm given a hypotenuse and one of the legs. I can just use what?
A squared.
A squared plus B squared equals C squared, Pythagorean's theorem. Yes?
Yep.
And if I use Pythagorean's theorem, I can solve for X very easily. But guess what? We're learning about trig. We're going to solve it using trig. We'll back that up. We'll put it into Pythagorean's theorem to show that it does work. So, let's take a look here. The first thing I need to do, though, is if I wanted to solve for the sides using trig, I need to know an actual angle. We don't have either angle. 90 degrees doesn't work, okay? So therefore, I have to solve for M first before I solve for X. And so, let's look at M. If I'm looking at M, or from M's perspective, 3 is considered the opposite. I'm going to change colors and write that on there. Guys, I would highly suggest that you do something like this for the first couple problems, because that way you're less likely to make mistakes. And 7, we will call the hypotenuse, and X would be adjacent. Is everybody following with that? Okay. So those are your sides compared or from angle M. So what I need to do is I need to look at those sides and say which of those sides are the ones that I absolutely for sure know. What sides? Opposite, hypotenuse. So go back to SOHCAHTOA. Wait a minute, it's not on this page. I will write it on this page. Which one deals with opposite and hypotenuse? Sine. Sine is opposite over hypotenuse. So what does that mean? That means that I can actually take the sine of M is equal to the ratio of O over H, or opposite over hypotenuse, or 3 over 7. Did everybody see how I set that up? Now, SOHCAHTOA helps us establish that ratio. The sine of this angle is 3 over 7. I could have done it with the cosine and tangent, but if I used tangent or cosine, I would have had to use x. That's an extra variable. I can't solve an equation when there's 2 variables, right? I only can do that when there's 1. So now I have to think about this and say, how can I get M by itself? I need to do the opposite of signing it, right? or the inverse operation of sine. So I'm going to take the inverse sine of both sides. Watch how this works. Remember, it's the sine with the little -1. And if I take the inverse of something, it should cancel with itself, right? These will cancel. Now you're left with m. But what I do to the left side, I need to do to the right side. This is where things get a little tricky. I need to make sure I place it in front. I'm taking the inverse sine of the whole side. And so, what does it look like? It's m equals the inverse sine of 3/7. Now, obviously, I'm going to have to take my calculator out for this because I do not know this value. It's going to be a not so nice number. Eventually, we're going to learn some things about sine, cosine, and tangent so we can actually get some ideas on what things are going to be. Eventually, you will know 30, 60, 90s and 45, 45, 90 triangles by heart. But for right now, what is the inverse sine of 3/7? Now, wait a minute, guys. Do we want to be in degrees or do we want to be in radians? Do you even know what radians are? No. So make sure your mode is in degrees. Because if I told you, hey, I'm 4 radians, you guys wouldn't know where I'm at. If I told you 4 degrees, you could probably give me a 4-degree angle, right? Roughly, give or take. Or 30 degrees or 45. I'm assuming this is going to be less than 30.
Thank you.
So it looks like m equals 25.4 degrees, give or take. It's got 25.3 something, 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 something. So therefore, 25.4 degrees. Is everybody okay with this? We now solved for m. Guess what? I can use m and I can solve for x. Does anybody have questions? Can anybody not get 25.4? Now, I'm going to use this fact that we are telling us, or we found out, that's 25.4 degrees. And now, if you think about it, I know every piece about this triangle except for x. Wait a minute, Mr. Konchak. There's a whole nother angle here. Could we figure out that third angle? What's the connection between all three? They add up to 180. If one of them's 90, the other two have to add up to 90. They're complementary. If one of them is 25.4, then the other one has to be 64.6. So we could just subtract it and we could find that out. We have that. The only thing we don't have is x, which is adjacent. Which is, if you go back up to SOHCAHTOA, adjacent is in cosine and in tangent. Now remember, these letters, the first or the second letter is the top of a fraction, the third one is the bottom, right? Where would you rather have your unknown? On the top or the bottom of a fraction?
On the top.
On the top. So which of the two, ka or toa, do you want to place adjacent? On the top. I would rather use cosine. So what does that mean? That means that the cosine of 25.4 degrees is equal to what?
X
Over
over the cos, so
7
7.
over the h, hypotenuse. Cosine of 25.4 is x over 7. How do I solve for x?
You do cosine of 25.4 times 7.
Yes, I'm just going to multiply both sides by 7. So x is equal to 7 times the cosine of 25.4. Bless you. And you take your calculator. I would personally do the cosine of 25.4 first. hit enter, and then multiply that by 7. You will get probably something closer to 6.32.
Yes.
I'll pause it to make sure everybody's on the same page. Just to check ourselves, I'm going to erase the stuff up here. Just to check it. Watch what happens. A squared plus B squared equals C squared. I can check this thing out. 6.32 squared plus 3 squared should equal 7 squared, yes? What is 6.32 squared? First of all, is this going to come out exactly right?
No,
Why?
because we rounded it.
We rounded numbers here, guys. But what is 6.32 squared? 39? 94 plus 9 should equal 49. That ends up being what, 48.94?
Yeah, so not really right.
48.94 equals 49. Knowing we rounded, that's okay. We were able to check to make sure we did something right. Knowing this, the answer probably really, truly was the square root of 40. Take square root of 40 once on your calculator. You'll end up with 6.3 something. Yada, 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 yada. So that is the correct answer. So we're going to end it right here, and you guys will have worksheet for day 2 homework on solving right triangles. Have a great day.